Hello all and welcome. I'm Bruce Taylor with Data Center Dynamics and welcome to another in our series of DCD debates. Our theme today calls us to answer the question, what does being AI ready mean for the data center and its operations? This is a very big conversation. I've tried to chunk it down as best I can, but just bear with us. It's going to be a very full and fast hour. I'm skipping any usual introductory remarks because there's really nothing that I can add that won't be covered in this with three great panelists. A couple of housekeeping details, if I may. You'll notice a Q&A button on your screen at the bottom. Please ask questions as we move through. We'll try to answer them in the webinar itself. If we do not, you will be answered by email. So please keep them short so that our panelists can address them, but be interactive with us if you can. Polling questions, there will be a number of polling questions that you'll see on your screen. Please answer them as quickly as you can. They're very short, very easy, and we'll report them out as we go. You'll also see a widget on your screen for downloadable resources, and this is a good place to go to get any other information that you may think is helpful. So let's go right to our panelists, three really very different voices coming from very different perspectives, and that's always good. So Greg, I'm going to start with you. Please introduce yourself and say about a little bit about what you do in life and in your work.
Sure. Thanks, Bruce. Hi, everybody. I'm Greg Knowles. I am the offering leader for a portfolio of solutions from IBM that apply analytics and AI to infrastructure, largely industrial type of infrastructure that are operating 24/7 to a large degree, producing lots and lots of data. And my customers want to make them run more efficiently and more reliably. So I own a portfolio of offerings that bring those capabilities to my customers.
Susanna Kass, you're up.
Hi, my name is Susanna Kass. I'm the Executive Vice President for numerous companies. One of them is Baselaye, which basically does modular data center. Including that, I also work for Nlyte Energy, which focuses on renewable energy. And for today's purposes, I think my role was to more sharing my experience about consuming AI, using ML, relating to the data center operation that I've done as a COO for eBay International and at Sun Microsystems and also Hewlett Packard running the worldwide data center. So glad to be here today. It's a topic that I'm actually passionate at because I'm one of the co-lecturers at Stanford University relating to this topic. So thanks for having me.
So Susanna, we're having trouble with your audio. Would you try dialing back in and see if it cleans up your line? Thank you.
Yes, I shall do that
Enzo,
right now.
Thank you. Enzo.
Thanks, Bruce. So my name is Enzo Greco. I run strategy for Nlyte Software, which is a top provider of automation and optimization solutions for data centers. And one of the particular areas I've been leading and focused on is applying AI and machine learning for data centers.
So there's a great place to start, right there, Enzo, if we may. And Greg, I'm going to ask you to respond to it from your perspective first. And that is, I want to make sure that people understand what it is when we are speaking about AI as it relates to any industrial use. But in this case, I believe that we really need to understand the difference between AI, machine learning, and deep learning or cognitive compute. So would you take a minute and just take us through that?
Certainly, yeah. From my perspective, AI is somewhat of an umbrella term, and actually would encompass a lot of the other things you referenced and different forms of analytics. But what I think differentiates AI as a collection is this notion of systems and solutions being able to reason and to learn. We see this in our solutions for in industrial companies. This idea of reasoning for us, for humans, means we can take in lots of different inputs. We see lots of different variables, and we come up with a judgment. I put these air quotes around this judgment of what the best actions are to take. These things are rarely black and white, and yet we're able to make these decisions very quickly. The idea of AI is being able to mimic a lot of that sort of human fuzzy logic that we see. So how does that translate in the software world? Well, we accomplish this fuzzy logic via techniques such as machine learning, deep learning that Bruce referenced, and even statistical analytics that give us predictive or forecasting types of models are all sort of variations or supporting themes underneath AI, right? And these techniques essentially provide confidence scores, and that's very much analogous to human judgment, right? We call it gut or instinct in some cases, but in our heads, we're essentially coming up with confidence scores. Do I think path A is going to be best or path B? And in my head, I'm not really coming up with an 80-20 calculation, but that's more or less what's going on. And so we do that more specifically with machine learning, deep learning, and statistical analytics. I think another component of that is that AI systems should learn over time, right? There should be a way for them to get better. And that can be either automated or it could be supervised. In other words, a human comes along every now and then and says, these results don't look that great, but with a couple of tweaks and tunes, we rerun some algorithms, and now our overall model is better. My last point on cognitive, which I think often cognitive gets interchanged with artificial intelligence. I think of cognitive a little more specifically, but here's how I relate it to AI, and that is with AI, the ability to understand unstructured data is very important, and it's an inherently human thing. And so when I say cognitive, I usually think of it's things like that humans are pretty good at, right? So this notion of understanding unstructured data, things like sounds, visuals, and images, or even things like smell. Believe it or not, we've done some solutions where we're using sort of chemical sensors to detect smells. But they're incredibly hard things to quantify. So again, it comes back to that fuzzy logic. How do I describe, the smell of, my ribs cooking on the grill? You can't, right? I mean, I can put a number to it at some point, but that's what we're doing with analytics, is creating ways to sort of quantify and then feed all kinds of different data, including unstructured data, into the algorithms that give you sort of a more holistic view of things in an AI context.
Perfect. Enzo, have you got a thought to add to that?
I do. In fact, if I can if I can complement some of the points that Greg just made and make it very specific to the data center. So we find it as a very pretty clear distinction, AI and machine learning. Machine learning tells you what you don't know. So AI does a great job in automating the rules and the systems and the processes that you give it. But machine learning finds the new patterns, finds the hidden value in all of the data that you have. And that's why machine learning, we're finding, is so important in the data center, because while AI does automation, machine learning does optimization.
And Susanna?
Yes, my belief is artificial intelligence actually genuinely was introduced in the early 50s, and the U.S. Department of Defense, specifically a division called DARPA, which we all know stands for Defense Advanced Research Project Agency, has piloted AI to basically actually do some street mapping that we all are now can live without the GPS that we have. And this has actually, frankly, has been done in the 70s. Before we actually currently now even known about Siri or Alexa or Cortana to be known to the consumer. So, but I also agree with the earlier speaker, basically mentioned it has actually gained more popularity now because of the increased data volume, advanced algorithms, and improvement that can be done in data center. So I think later on today we can probably talk a little bit more about the specific application. But specifically, I think this technology actually helped to address formal reasoning, including the early exposure that it has proven itself of its value on a decision support system. But now it actually can enable us to have more business insights in a very credible, precision way, and also enable some new business model from a smart search perspective to augment human abilities in speed and capability potential.
So I want to go to the second point. I'm going to ask each of you to address this relatively briefly, if you can. Greg, it is your field specifically, but Enzo, you may have a perspective on this as well. Are we now really talking about bringing the industrial IoT that we think of on the shop floor and we think of in logistics and supply chain, things like that? Are we now seeing the data center as an application of the industrial IoT? So, Greg?
Absolutely. When I've been in the data centers that we run for our customers here in Raleigh, North Carolina, and the first time I went in there a number of years ago, I was actually shocked at the amount of industrial equipment sitting behind that data center. The cooling equipment, the pumps, the piping for all the waters, the pressure meters, the cooling towers, and all that sort of stuff that sits outside. It's actually very much an industrial environment. They've got all the SCADA and PLCs and control systems and things that are monitoring the water temperature, the pressure, the flow, all that sort of information that helps keep a data center cool and running. So yeah, I think the data centers today are simply a variation on industrial environments. It's all the same stuff.
And then,
so
do you know?
I can add.
Yeah.
So if I can add to that, so as you know, I came from the equipment side, and we see very clearly two uses of IoT in the data center. And as Greg just said, the data center is a perfect example of industrial IoT. So within the data center, given the huge variations in equipment, in providers, in protocols, in control systems, IoT has great promise in normalizing a lot of that, in normalizing the equipment, normalizing the protocols. So within the data center, there certainly is a lot of interest in IoT, but there's a more interesting application, I believe, outside of the data center. So there are a lot of external systems, such as weather, such as telemetry, such as seismic information that could have an important impact on the data center. And if you look at IoT, it's a perfect mechanism for that wide area geographic collection of this type of data. And so both within the data center and outside of the data center, IoT has great promise, and certainly it's getting a lot of traction both from the providers as well as from the data center customers themselves.
Susanna?
Yes, currently the industrial IoT, as I see it, or as it is being defined in the industry, focus on the optimization of operational efficiency and rationalization. Furthermore, it actually makes a tremendous amount of improvement in automation. And personally, for me, I've actually seen quite a bit of value from the ideation, design to predictive maintenance. And specifically, a couple of the experience I have in actually working in this environment with data center is the interaction of that with smart grid. There's a lot of breakthroughs and leapfrogging that we actually were able to achieve because of the linkage between data center and the smart grid in terms of automation and control of the supply and the network transmission distribution of the electric grid, which is extremely important for a data center to achieve the reliability and capacity planning.
So I want to jump now, if I can, bring this to another level. Enzo has written relatively recently that we're at a disruptive moment in the data center, and no data center operator ever wants to think of anything that has to do with disruption. So I want to take this at a philosophical level. But we are at a transitional point in the physical facility of the data center. And it seems to me that both advanced DCIM and employing machine learning is going to be critical to how we operate in the future. So, Enzo, I'd like you to reflect just a little bit on what you see as driving this now in the modern digital transformation era data center.
So an interesting question. So let me have a few comments on it, and I'm sure Greg and Susanna can refine it. So I don't think it's a DCIM issue as much as a data center management issue holistically. It's larger than DCIM. And the issue is that if you look at the scale and complexity of data centers, it's very hard to manage those facilities with traditional rules, with traditional processes. And given this, again, the scale and complexity and required optimization that's now expected of these facilities, AI and machine learning are playing a very important role in finding the unique patterns, finding the optimal operations, finding those processes that we hadn't considered before. And again, I think it all comes back to, in the modern data centers, they now need to compete with alternatives that in many cases they didn't have to. And I think that's a very unique and driving role for why machine learning in particular is playing such a large role in data center management.
I want to take just a minute and report out the first polling question, if I may. And this is on AI and how people now see it. We have 3.4% of the audience who say that they have it now installed and are operating it. 38%, 37.9% that say that they're planning on it. And the balance of people are saying that no, it's not on their radar. And that's 58.6%. So it's the 58.6% we're talking to today. So please ask your questions. So I thought that was interesting. Greg, do you have a comment on if you see the data center world as being in a disruptive transition, that what's coming is going to require a different level of predictive analytics, things like that?
Yeah, definitely. Just to add to what Enzo was saying, I see this pattern playing out with almost all of my customers, right? And when we start to talk to them about analytics and solutions, we often come back to the data. And what they're dealing with today is just such a tremendous amount of data because so many more things are connected. They're censored. There is the ability to add sensors very easily to existing pieces of equipment. So we're flooded with data. And the humans that used to sit behind terminals and screens and monitor things, or they got alerts, or they got emails when something was going wrong, it's just simply too much data and too many things going on now. And again, to echo what Enzo said about the complexity of data centers, right? So we're pretty good at consuming, 3, 4, 5 sorts of variables going on. But when you've got 10, 15, 20 variables going on, it's just beyond us to start to correlate what's going on between variables and how different pieces of equipment are interacting with each other. So the theme, really is that data and the complexity is overwhelming what we used to do. this is happening in industrial with my clients in industrial as well as the kind of stuff that's going on in the data center. So we need AI and machine learning and automated technologies, as Enzo said, that can make sense out of the noise in the data and find the events and the things that we really need to pay attention to investigate or take some action on, and to alert us to patterns and trends that just aren't readily apparent because of the sheer amount of data. We see the exact same thing playing out in industrial.
Susanna, do you have thoughts on this?
Yes, I'm actually very intrigued with the percentage that you share regarding the 58% saying that it's not on the radar. That's interesting. I wonder what these folks do. Maybe you can type in to the webinar in terms of what is really your role. I would be very intrigued to hear about it. The reason I state that is the following. Forget about all these big terms about AI and ML. So sometimes these words can be a little bit intimidating. Let's just focus on what we really do, right? So reflecting back about 11, 12 years ago, something like that, when I was running eBay, and one of the applications that we do is what we call a contact center application called Trust and Safety. What we basically done at eBay in a platform, we aggregate various type of data from disparate sources in a variety of formats, and we bring them together to not a very high-pay individual, or I guess at that time we don't have a contact agent robot, which currently now is in place right now at eBay, to basically serve a very common customer inquiry that we have no idea what that customer is actually going to ask us the question. But we need to bring together all that information and insights at his or her fingertips for this contact center agent that can actually answer the customer questions. So if you go back and you listen to the other speakers who are experts in this field, and they have experience about working with artificial intelligence or deep learning in an industrial Internet of Things environment, what you're basically seeing is these technology is something that you must adopt because it enables evolution. It's not a disruptive moment. Actually, I would plead to argue a little bit with you, Bruce, that it's not a disruptive force, but it's an enabling evolution because you must be able to deal with the massive volumes of data, the varied frequency, the different types of complexity of different data relationships. And my favorite category is what I call the messy data that you don't know how to categorize them, but you need to make sense of this information. So the technology that we discussed today would actually help you to get to what you wanted to do much faster. So I like folks to reflect on that and saying, hey, forget about the big terms. Maybe there's something currently right now in my operation and data center that I'm already doing some of these other functions, but now there may be some new technology coming around that can actually accelerate it and actually get you more precision and faster in terms of the way that you want it to get done. And who doesn't want to have the ability to achieve incredible accuracy in what we do every day? Why wouldn't you want to do that?
I think that was very well put, Susanna. I appreciate the
I'm just going to run right out and buy right now. Absolutely, perfect. So let me see if I can take one of the questions that we have here online. And if you, Enzo, I'm going to throw this to you because I think you probably have the clearest eye to it. When you look across the addressable market of all the categories of data centers, all the footprint sizes, all the types of data centers that there are out there, how large is the addressable market for AI, for machine learning in data center management? Is it literally 100%?
I think eventually, and in fact, I would like to build off a comment that Susanna just made, and it's actually one of the trends we see in the market. I think eventually it needs to be, because if you look at what happens in the data center market, in many cases now data centers have, and I believe we'll address this later, but optionality. You have a great deal of options in where you place your workloads and how you manage your data center. And what is happening is data centers are now the benchmark for efficiency, the benchmark for availability is increasing, and it's increasing by the top players in the marketplace investing heavily in this kind of technology that we're speaking about here. But as those facilities have ever better benchmarks, the rest of the industry needs necessarily to catch up to remain viable. And in fact, some of the analyst firms had some very interesting research reports exactly on this. So I think you always have the point of early adopters. You always have the point of evolution, exactly as Susanna said. But what happens in this market is as you get ever better benchmarks, as you get ever better efficiency, those become leading options that the rest of the market needs to also adopt to remain viable and competitive.
Thank you. So I want to take another polling question if I can, because this may help Susanna with her frustration. And this is on the importance of AI in the data center. And 96% answered that yes, it will be important to the future of their data center, and only 4% said no. So I thought that's a nice way to balance that out. I think it's not that they don't have an interest; it's that they're just not there yet, which is the whole purpose of this webinar. So I'm going to throw this to Enzo next. This next question, and it really gets at what is it that we really mean by software-defined infrastructure or the software-defined data center. Are we really moving toward it being self-monitoring, self-predicting for both maintenance and equipment failure? Are we moving toward being self-healing? Do you have examples of where that is now being applied? So Enzo, I'm going to let you take that one on first.
So let me, I appreciate, so let me go first, and I think Susanna, especially in her role, can add some specific color to it. So what we see a lot is when you get down to software-defined infrastructure, what we believe customers are really trying to do is to ever more virtualize their facilities. So we understand certainly virtualization down to the software level, down to the compute, network, and storage level. But what's increasingly happening is extending that virtualization ever further south, ever down into the critical infrastructure. And that gives you a great deal of flexibility and agility in how you manage your data center and how you have different components working together and how you can ultimately, which is the point of this call, how you can ultimately optimize all the different pieces that you do have in a data center while shielding yourself from the vagaries and the differences between the equipment itself. So often when we see software-defined infrastructure, it's really virtualizing ever further south the equipment in the data center to achieve that optimization and to achieve that flexibility that's becoming needed ever more. And Susanna, I think particularly in the roles that you have and have had, you can probably add some specific color to that.
Thank you. Should I go next, Bruce?
Oh, absolutely. Jump right in.
Great. So I'm going to talk a little bit about the data center of the breed that I'm actually interested in, because data center is kind of like snowflakes. They all look about the same, but trust me, they're all different. And I've experienced many times all over again in terms of different variant of them. So I love data center because I genuinely think they're all snowflakes. So specifically, I'm going to talk about one type that I have most experience with, and one of my passion is actually the hyperscale. So for the hyperscale data center, I see there's 4 areas that this topic will be extremely relevant in the area of correlating its own performance management, efficiency, and optimization. The first area, if you will take note, in my opinion, is automating the repetitive learning and discovery of new information through correction of data. The data comes to us need to have contextual state, need to have modeling of different scenarios in terms of configuration, security, or performance management. If you're just looking at the data and you're just going to look at it faster because the data come in different way and you deal with a massive volume that we talked about from the various formats, then you only sit in the zone that I call the I know zone. You already know that information, okay? So maybe it helps you a little bit because it accelerates the way that actually you're going to do repetitive learning, but that's not good enough. You need to be more disruptive in your own way in terms of thinking about how the technology is going to do work for you to push yourself out of the I know zone into the I don't know what I don't know zone. So this is actually where AI and deep learning comes in with the experts that just shared with you in this seminar, is not only you learn how to correlate data from a variety of sources, it's about pushing that boundary to find out what is the complexity of the data correlation that gives you this predictive analytics that you don't know and you don't see. The second area is adding intelligence. If we don't continue every day do things with intelligence, that you might as well all go to sleep because it's just not worth waking up in the morning. So automation in form of just natural language processing is good, is essential, but it's insufficient. So what you need to do, look at who are the products that's actually basically is just flying off the shelf. By just adding a conversational platform like the Alexa, all of a sudden everybody wants one on the kitchen table. So bringing it back to the data center operation rather than in the consumer kitchen, I would love to be able to chase the moon function, which is a backup function that we all do. When you have data center globally in a hyperscale in different time zones, I love to implement the chase the moon application that I can actually use my resources around the global footprint where the energy is actually the cheapest, which is exactly where the moon shines, is actually where the energy is usually the cheapest. So I can immediately actually save a lot of money and basically perform the same function in a hyperscale environment. By learning just one thing very simple, location particulars and the energy cost and the tariff rate. Third area is what I call progressive learning algorithms. You guys are experts in that. Many of you out there might be the one that inventing these algorithms that I love to learn from you. Algorithm teach itself and a model requires no human intervention. No human intervention is a good thing because it eliminates human errors. And when you start talking about optimization and performance improvement, you really don't want to have a human in there making errors to achieve your least cost methods. So at least you want to kind of have that as a control case. The fourth one is actually my favorite, is the ability to achieve incredible, but not perfect accuracy. I make the mistake trying to be perfect. Well, forget that. Life doesn't need to be perfect to be wonderful. You need to have the ability to achieve incredible accuracy in everything that you do in data center, because everything that you do is a data and it's a decision that you made that would actually affect reliability, capacity planning, system stability, resilience, and oftentimes cost. So I plead you all to give it some thought in terms of everything that you do today is a status quo, and question yourself whether you are doing the best job that you got paid to do. And I think you would think about that there'd be room for improvement.
So with that, I'm going to move to a question because I think it follows on from this. And this is from a senior data center manager at a very well-known, high-profile bank, financial services. And it really goes to something that, Enzo, you and I talked about, and I'd like to have you address, and it kind of moves off our questions here. And that is the nature of big data, the nature of data retention, and whether data center operators, when you're a very large financial services institution, you can gather lots of data from every site you have around the world. However, a smaller operator may not have the same scale of data sets to be able to run a machine learning algorithm across. So I'd like to just talk about that for a minute. Across the entire portfolio, the entire market, do data center operators generally have enough data in order to be able to use analytics and predictives reliably?
We see that. And in fact, firsthand, what we see is for a given operation, they typically have the right kind of data input. So for the larger operations, sure, they'll have both larger data sets and maybe even richer types of data. But they also have more complex operations, and that richness of data certainly helps in achieving the optimal outcomes. In a smaller operation, probably is a simpler environment, probably less vendors, less complexity, less options for everything from managing the critical infrastructure to the workloads. And even in that simpler environment, however, they probably have just the right type of data to help them apply these optimization techniques.
And so, Greg, as you look across the field of industrial IoT, does that hold across other applications as well in other industries?
I think so. And just to be a little more specific, we're seeing customers have all kinds of data. Often they have more data than they know what to do with in industrial environments. I think if we dug under the covers in the infrastructure in a data center, that would be the case as well. And fundamentally, I see this question in the Q&A section about the amount of data needed. So, specifically, we can do very lightweight analytics with a very small amount of data. In fact, you can apply very simple machine learning techniques for anomaly detection, basically against a running stream of data that may only go back hours or days to gain insight about, is anything in my data center behavior changed? The workloads or the behavior of this infrastructure, this piece of equipment, is it different than it was 24 hours ago? But as you start to get into deeper statistical analytics and forecasting and building predictive models, often you need several months worth of data. There are cases where we want to see a year plus of data if we need to collect information about different failures or different symptoms and things like that to actually get a good profile of the behavior of pieces of equipment. So it can vary pretty widely, but I think you can get into some deeper analytics and start to build statistical models and predictive models with, as little as 3 to 6 months of data. If you're not doing all that sort of data, you may want to retain it for, historical sort of descriptive analytics, building reports, comparing seasonality, from one quarter to the next or 1 month to the next kind of thing. So it depends on what you want to use it for, but, data is becoming more and more important, and I'd say, if you're not retaining data, you need to start, and it will start to look and feel more and more like big data, in those sorts of volumes. But again, it depends on the scale of the data center and how many data points and different things you're collecting. But I would suggest to everybody to get started somewhere, right? Get started with that data. See what's in your data. Make sure you've got good quality data. Or do you have the right sensor readings and things like that? Is the data center, the machines, the hard drives, the network, is it all instrumented at the proper level? And the infrastructure, same way. And look for those hotspots, places where you have problems, and that's places where you might need more data. And it's really pretty inexpensive to get started collecting that data. I would just suggest to folks to get started and see what you can learn from the data that you've got, or look for places where you might need to add more or improve the quality. And then you can get started with the analytics and machine learning and AI.
So I'm going to move
Bruce,
to a
I'd just like to add, Bruce, I'd just like to add one really quick thing. Every data center generates a tremendous amount of data, much of which has traditionally been ignored, as you know. And with some of the techniques and with some of the tools that are now available, that a tremendous amount of value can be discerned from that existing data that a data center is already generating.
Yep, I would agree, Enzo. We see the exact same thing with our
Right.
industrial customers. They typically have a lot of that data. They just don't know. They don't know where it all is. Let's say they haven't brought it all together, and they haven't really rolled up their sleeves and tried to analyze it.
Right, right.
And they certainly haven't tried to analyze it in a kind of a real-time environment either.
That's right.
That's been my observation. So I want to go to another question from someone in our audience who I know is a senior manager of a very large co-location services provider. They build and operate best-of-breed Tier 3 data centers. And his question is, I'm interested if there are, one, any reliable metrics showing ROI in AI solutions, excluding theoretical assumptions of the cost of downtime. And two, are there any metrics showing reductions in downtime for well-run Tier 3 data centers pre-AI versus post-AI implementation? So Enzo, you're probably the one person who has a real clear eye to this, and Susanna perhaps. So can you take that one?
I'll take the first stab at it, and it's a very good question. If we move where there is some very specific ROI already around machine learning and data centers, in many cases it comes down to a couple of areas. One is the energy optimization, particularly around thermal systems. So being able to either pre-cool areas, being able to change everything from the set points to the way the chillers themselves work. That is a very specific area with discernible AI. There is another area of optimally placing workloads, and optimally placing workloads allows you to have both a more efficient data center, because you can, for example, aggregate your different workloads in common areas and then methodically shut down other areas for energy efficiency. So those are two well-known areas. In terms of availability, this is certainly the goal, that this is one of the key reasons that data centers and all their complex systems exist. I don't know of literature yet that directly ties increased availability to optimization techniques, and the reason for that is many data centers are already very optimal in terms of availability, and there is a question of any increased availability. Is that due to the AI system? Is that due to changes in the equipment itself? So those are just some first-hand ones. There is a great deal of interest, certainly, in workload management and energy optimization. Susanna, perhaps you have a different view of it, especially coming from your background.
Well, thank you. I'd like to share what I learned from my customer, which I love to do my job every day. So specifically, I don't think my friend would mind me mentioning his name. Sean from Microsoft actually has a blog that he actually not only talked about how to do clean energy generation in the rack level, that Microsoft is actually leading that effort, and he is definitely leading that. In terms of just basically having clean energy generation at the rack level. So what does that mean? That means, that you immediately eliminate carbon emission. You don't use the electric grid that is actually maybe not as clean. And at the same time, it moves the location of the generation right at the rack level, right? So by just moving those two components, we were actually able to calculate, or he was able to calculate in a couple of the data center, these hyperscale, in terms of achieving a return on asset and a cost reduction improvement that is extremely significant. So let me talk a little bit about the number. So go in and understand your own. If you don't, please do me a favor and know where you are at in life. Is how much does it cost you currently now to run 1 megawatt of data center in your own operation? If you don't have that answer at your fingertips, I highly suggest that you listen to the experts on the phone on a call this morning, and basically be able to use the data that already exists, except that you're not looking at it correctly. So, okay, first of all, know that number. And usually if you come down to about a single digit, you're fairly good. But right now, I'm actually looking at a 3 to 5 million installed 1 megawatt is possible using clean energy generation. So it really eliminates the myth about using clean energy and renewable is more expensive than grid. That is not true. And the other one that actually I'm dare to say that I'm actually doing a couple experiment with some of my customers is actually getting rid of the entire UPSs in terms of the standby. All the standby asset can actually genuinely not be there if you actually have a very strong relationship with alternate source like an energy storage on site, or potentially have place your data center in a reliable grid. By actually not having these extra assets sitting around, you go do your own math in terms of how much of the millions or the hundreds of the millions that you potentially can save because they are literally standing by. So those are the two use cases that I felt are low-hanging fruit. The only reason why you don't do that is because the level of emotional preferences and comfort zone, but they're definitely feasible and available today.
So that just answered one of the questions from another large financial services group. So thank you for that, Susanna. You didn't even know you were answering a question. This one comes from a very large mobile wireless and telco provider. And it is, how is AI self-healing? Predictive analytics may be able to diagnose a potential issue, but how would the AI be able to repair this issue without human intervention? Can you provide practical examples of how this would occur in the data center environment? So, Enzo, I think, again, you're probably going to have the best look at self-healing.
So, Bruce, I think I can also tie in a little bit from the previous question. So one of the clear areas that AI is used in industrial environments is around predictive failure and preventative maintenance. If you look at the poster child for AI in the industrial environment, it is aircraft maintenance. It is large moving stock maintenance in, for example, locomotive maintenance in railroads. It is exactly predictive failure and maintenance. And the same is true in the data center. So if we look at the mechanical systems, what are the systems most likely to contribute to failure? It is exactly the mechanical systems, and there are quite a number of mechanical systems in the data center. You have certainly the servers, so being able to predict their failure is critical. You have the thermal systems, from the fans to the chillers and compressors. Each one of those is a failure point. And then within UPSs, which certainly are critical for recovery and ongoing operations during a power failure, you have batteries and what the life and status of those batteries. Each one of those is a perfect area that has already been applied and has already benefited from AI. So in terms of increasing the availability of data centers, to that prior question, it's exactly and already being applied to the mechanical systems in a data center, just as it's been applied with great value in many other related industries. On the point of self-healing, I'm not sure that there is that non-human intervention for mechanical systems. Can it be achieved for virtualized systems and for software itself? Of course it can. And that's one of the reasons that the software-defined infrastructure is so important, because I can now easily move at a software level across different hardware components. I think the real question is the definition of self-healing. No one really expects a fan to suddenly replace itself. However, if I have enough virtualization and enough intelligence, can I preemptively move that fan load to a different system that is operating very well? Yes, I can, and that is an example of self-healing.
Excellent, thank you. So I want to take a jump here. We're now down to about the 10-minute mark, and I want to move to a new topic, and it takes us away a little bit. It changes the focus from what we have always assumed to be data center and infrastructure management, and moves it instead to where I think most of us actually believe we're headed, and that is toward workload management, workload optimization. Enzo, you've written a lot about recently, and your use of the term, and I don't know if it's unique to you, and it's just it's new to me, but I like it. Optionality. So I want to talk about the use of machine learning in helping data center operators determine the optional placement of compute workloads. So can you take that?
Sure. There's two threads to it. So the first is very much a business thread. So if you look at the concept of optionality, this is a top topic among senior executives and the senior team in most organizations, where when they look at a data center, an enterprise-owned data center, it's a critical facility, it's a strategic facility to the operation of the company, but it's also quite expensive in terms of CapEx and OpEx. So one of the discussions that we see happen firsthand in nearly all organizations is what is the right disposition of the data center? And it could very well be that the data center remains exactly intact, perhaps ever more optimized to compete with alternatives. But on the point of alternatives, if you look at it from the workload perspective, and data centers, colos, cloud, all of those facilities exist for the ultimate goal of running workloads. They don't exist in and of themselves. So if you look at it from the workload perspective, suddenly there is immediate optionality on where I can optimally place workloads. Perhaps I continue to run them in my existing facility with an ever greater eye towards availability and efficiency and optimization. But I also have immediate options such as for Office 365, for example, going immediately to a SaaS option. I have colo options. I have cloud options. I have multi-cloud and hybrid cloud options. So this is the concept of optionality. And one of the key questions we see coming from customers is, am I making the right decisions? Do I have the right data points? Do I have the right metrics for determining where to best run my workloads? And if you look at, again, going back to the point that both Susanna and Greg emphasized before, if you look at the complexity, the scale, and the optimization of where do you place your workload when you have such a very rich environment, also extending to edge, now you have such a rich environment that it's really hard to get optimal outcomes without tools like machine learning and AI. And that's exactly the state of the art that we're seeing. And really much of it is being driven by where do I optimally place workloads and how do I optimally disposition my data center assets and all the other options that I have in placing those workloads.
Susanna, do you have a thought about that?
Yeah, I'm actually going to come at it a little bit differently. So don't mind me, audience. I'm actually going to humor you with my way of thinking. So I think everyone probably know about how many new servers and how many new workload you're going to provision. You have that because you basically plan out your staff in terms of how you're actually going to provision and get new applications out there. But I'd like to challenge you to actually have a metric that you probably don't have it at your fingertips is how many of the servers that actually or workload that you're actually going to decommission or unprovisioned? And I'm willing to tempt that if you take the poll, majority of you guys do not have that answer, or you actually don't even know you actually needed to do that because you're so busy, supposedly, very busy on focusing on provisioning on that. But we all know that if you leave all these ghost servers around and you have all these workload that you no longer need and you don't even know where they are at, they're actually kind of like the vampire. Happy Halloween, everybody, early. They're actually sucking away your resources and distracting you from what you're actually going to be doing. So that is really not business agility. So you need to look at optionality, and the other way is like, hey, what do I have to do to get ready so I can actually take the advantage of what Enzo is teaching us to take advantage of these options. So my thoughts on that one is, because I focus so much on energy and cost from an OO perspective, it is extremely important that you need to look at the holistically about what are the things that you actually don't need, that you need to take it off, and what is a systematic way to be able to do so. And since you don't really like to do that job anyway, why won't you want to give it to a deep learning and an AI and an ML bot so they can actually do the work and the house cleaning for you for your server, which you knowingly know is extremely important to be able to decommission workload that's no longer there and unprovision the servers that is basically taking things away. And in a way that you basically will be able to gain back some resources, doing ROI in a different way in terms of optimizing your own balance sheet.
That's a powerful statement. Thank you. So we're
Yeah.
now down to just 4 minutes more in this session, and I want to open this up to a new topic area, if I may, and that is just getting your quick sense of, as you look around the data center management space, are data center operations management professionals, are they behaviorally and organizationally prepared to take on AI? And who do they not have on their teams that they should have? Who else in the organization should they be talking to? So, Greg, I'm going to let you start with that, with a short answer, because you come at it from an industrial IoT standpoint, and you'll have other examples, but you may also be able to now reflect on it from a data center perspective.
Yeah, this is an interesting question, right? And I'm going to try to relate it to some of the roles that we see in industrial environments. I think there's certainly analogies or parallels to the data center, but two general roles and then a more specific one that I think is probably much more to the point for this environment. But in industrial, in production environments, we work with two roles that have sort of complementary objectives. One is the operations engineer, and one is the reliability engineer. And I think it's interesting to think about these roles translated to the data center. An operations engineer is essentially focused on throughput, right? Getting more out of the infrastructure that he has in place. So producing one more widget, producing one more car, for every operational shift that they run, right? So he's looking at the overall efficiency of the line, and what they can produce. The reliability engineer, complementing that, is really focused on keeping things running. So he's looking at different pieces of equipment, different parts of the system, and making sure they're running efficiently. Are they performing at their peak performance, and are they reliable and available? I think you could translate those two angles directly to the data center. Are we getting the most out of the servers and the infrastructure we have in place? Are we getting the most out of the cooling systems relative to the energy we're consuming and those sorts of trade-offs? And how do we keep everything running? And I know there are people in and around the data center that are focused on those sorts of things, but I thought it was interesting to make that connection. But I think more specifically, when we start to talk about analytics and machine learning and AI, I think the skills around data science are going to be increasingly important. We're actually in my solutions, we're trying to minimize the need for a data scientist with our solution. So we're trying to raise insights up to the line of business folks, the people who operate or using things day to day, the operations engineer and the reliability engineer. They're not data scientists, but they know how to apply analytics and they know what to do with the insights. But they do work hand in hand with a data scientist or someone with those data science skills. And I think the more data-oriented we become and the more data our solutions are using, the more we need to understand some of those data science skills. And in some cases, you do have to roll up your sleeves and you just dig around in the data. You look for anomalies, you look for patterns, you look for things that we haven't built algorithms necessarily yet to understand. So a data scientist come in and do some of that stuff manually and then helps build the right algorithms, machine learning, predictive analytics, and things like that we can then put into production as more automated detection or even action-oriented types of solutions in analytics. So that's my thoughts.
Thank you very much. So this does wrap us up, and we are now over time. Thank you all for staying with us. Enzo, Greco, great to have you with us. You're a powerhouse. Susanna, Kass, people should have sat up and taken notice. And Greg, thank you as well. And all, we're done for the moment. Please let us know if there's any way that we can help you in the future. And those people who we didn't get to answer your questions, you will be answered by email. Thank you so much.